Hello, I'm an old guy and I do maths. Today we're looking at the ideas of domain and range, which if you get into functions at all, you're going to strike. So it's a good idea to have a solid understanding of what exactly they are. Now, a good starting point is to say that the domain of a function is equal to the possible x values of that function. And the range is equal to the possible y values of that function. Now, what does that mean? Well, let's take a look at a linear function here, y equals x plus 1. The domain of this function is all the values of x, from 0 to positive infinity and 0 to negative infinity. So the domain of this we could write as something like this. Now, it's just occurred to me whether or not I should put equals signs in here as well. I don't think so, because infinity is not really a number, it's an idea. But the domain of this runs from, negative infinity to positive infinity. And as we know, this function can go on forever. So the same is true of y. So the possible y values of this function run from 0 to positive infinity and 0 to negative infinity, which basically means that they go on forever. So we could make a similar statement about the y values. This is the domain. And we could say casually, I suppose, that the domain of this function is infinite and the range of this function is infinite. There are no restrictions on it whatsoever. Now, that is usually, but not always, the case with linear functions. It is possible to place a restriction on the domain or the range, and we'll get into that a little later. Now let's have a look at another function. So here's a function that I've put in turning point form. Whoops, I should square that. And this is a quadratic. And hopefully immediately you notice that this thing has a minimum point. And what that means is that although the domain, the possible values of x, are completely unrestricted and run from negative infinity to positive infinity, essentially go on forever, this thing has a minimum point. And so while the possible values of x, the domain, gives us an answer of infinite plus or minus, or infinity plus or minus, watch my grammar, the range of this function only goes from this point in a positive direction. So the range of this function runs from -2, the lowest y value. So you could just say casually again that the domain is infinite, but that the range, or the y values, if you want to state it in terms of y, y is greater than or equal to -2 and less than positive infinity. So this thing goes on forever in this direction. Now that's very important, because this will be the first time in a discussion of this nature that we've seen a function which imposes a limit on the range but not on the domain. and that is because this function doesn't exist down here. It only exists from this point, and this is its minimum point. So, to recap, domain is infinite. There are no restrictions on it. The range is from -2 to positive infinity. Right, let's have a look at something else. Now, you may or may not be familiar with this function or this graph. This is the graph of a hyperbola, a hyperbolic function, a simple one. And the function itself imposes a limit on the domain and therefore on the range. Looking at this, what would happen if we put 0 here? Well, you can try that on your calculator and it won't like it. So what we know we can't do is we can't put 0 here. We can put any other number here. So our domain is basically unrestricted, but it can't equal 0, which incidentally means that the x and y axis are what are called asymptotes. If you've come across that before, you'll know the term. Putting it in a short form, the graph approaches but never touches the x or y axis in this form. We can move these graphs about, and I'll show you one in a minute where we do. But anyway, x can't equal 0, and therefore y can't equal 0 either. But the domain of this is all real numbers except for 0, and we can imply from that that the range includes all numbers except 0. Okay, so here's a slightly more complex example of the same thing, where you can see that I've done a couple of things to try and illustrate the effect of domain and therefore range. So if we look at this function, what we can see, hopefully, is that if we make x equal 2, we're going to get 1 over 0. And again, I suggest you try that on your calculator and see what happens. It just won't like it. 1 over 0, forget it. You'll get an error message or some such thing. So if this point here is 2 on the x-axis, this is effectively a line which this graph approaches but does not touch. If it touches this, this is equal to 0, and you can forget about this making any sense at all. And what this does is it lifts this function as this sort of thing does with so many other types of functions. So you see this with turning point form and various other things. It lifts this function from having an asymptote here to having an asymptote here at 1. And so what we can say when we look at this is that the possible values of x include all numbers except 2. And there's a restriction on the range, the possible values of y which this function can have. And I'm just going to write it like this. This is not generally how it's done, but just to illustrate the point, x can't equal 2 and y can't equal 1. So therefore the domain of this function is all real numbers except for 2, and the range is all real numbers except for 1. Now you can see this, if you can imagine that this goes on forever, that this curve goes on forever, and this curve goes on forever, and this goes on forever. This thing could go to, could encompass negative and positive infinity, but it can't encompass these two numbers because of the nature of this function. Thanks very much for watching this. I hope it was informative. See you next time. Bye.